Bonjour, class. Hello, how are you? Today we're taking a look at lesson 4.3, solving exponential equations numerically. Now, this is part one, ladies and gentlemen. This is where there's a simpler case or the easier way to solve. We will learn the next couple days how to deal with when we have more difficult expressions, okay? So taking a look, the keys that we need to remember today is that this is when we're solving equations, a definition of equation is that the left side equals the right side, right? So remember that when we go to solve today, the key is to remember to get any equation where the left side equals the right side. So all we need to do is make the bases the same, and then when the bases are the same, we just need to make the exponents equal. You'll find this easier when we do some examples together. And we did redo this in grade 11, okay? So here we go. Number one, rewrite as a power of 2. What does that mean? That means that the base is 2. So 8 is the solution to 2 to what power? Okay, how many times you multiply 2 by to get 8? And that's going to be to the power of 3. Taking a look at B, 2 to what power gives you 32? That's going to be 2 to the power of 5. 2 to what power gives you 64? It's going to be 2 to the power of 6. And be careful here, folks. This one it might be a little harder for you to realize. Okay, it's 1 over. What is 64 to the power of 6? We know that's 2 to the 6. But then because it's negative, it's going to be 2 to the negative 6. Okay. All right. That's all we're doing today, folks, is doing 4 questions to solve this, and then we're going to let you have lots of time to practice. Okay. So again, this should be a review from grade 11, but we'll just keep working on this. Okay. All right. First question, 5 to the power of x equals 125. So we want to get the bases the same. We have to think about which one we can make to the power of which base we can make the same. But I recognize that, hey, 5 to the power of x, I can't change that. But I can change 125 to a base of 5. How many times do you multiply 5 by itself to get 125? And that's going to be 3. Okay? Once the base is the same, therefore you make the exponents the same. So therefore x equals 3. So therefore your solution is 3. All right. We'll move on to a little harder one now. All right, so currently I have a base of 6 here. So it's 6 to the x plus 1. So I want to rearrange this right side so that I've got a base of 6. So how many times do you multiply 6 by itself to get 1296? That's 4 times. Now that the base is the same, therefore now the exponents are going to have to be the same. So x plus 1 equals 4. And now a simple matter of rearranging and solving a linear expression here. So x equals 4 minus 1. So x equals 3. All right, getting the hang of this? Hope so. Now we're going to deal into some harder ones here. Okay. Looking at this expression, folks, we've got a 4 and an 8. Is 8 a perfect, can we make a total of 8 be a base of 4? No, so we need to find another value that we can have both the bases of 4 and 8 be represented, and that base is 2. So 4 equals 2 to the power of 2, and then we still have that all to be multiplied by x plus 2 equals the right side. So currently we have 8. 8 equals 2 to the power of 3. And then all that's got to be multiplied by x plus 4. Now, ladies and gentlemen, if we notice, folks, that we've got power of a power law, so we can multiply these through. So I have 2 to the 2x plus 4, so just multiplying through using distributive law, equals 2 to the 3x plus 12. Okay, taking a look now, folks, the base is the same, so therefore our Exponents need to be the same because left side equals right side. So 2x plus 4 equals 3x plus 12. And we're going to simplify through with this. So we're going to have 4 minus 12 equals 3x minus 2x. And we're going to end up here with an answer of negative 8 equaling x. So x equals negative 8. Okay, so that's our solution. Okay, last example. So we have 64 raised to the x plus 5 equals 256 to the x minus 2. All right. Again, we've got to think, hey, how can we get these expressed in equal bases? It's easiest to try, first of all, see if you can get into the base of 2. So let's try that. 2 to what power equals 64? It's to the power of 6. And 256 is going to be 2 to the power of 8, all raised to x minus 2. Use your distributive law or power of a power. So we're going to have 2 to the 6x plus 30 equals 2 to the raised to the 8x minus 16. And again, once your base is the same, therefore your, for left side equal right side, therefore your exponents have to be the same. Okay, so let's simplify this through. We're going to have 8x minus 6x equals 30 plus 16. So we end up with 46 equals 2x. Divide each side by 2. So x equals 23. All right. Now notice, folks, in these cases, these bases were easy to get. You were easy to find a common base. That's not always the case, and we're going to be learning some harder examples in the next couple lessons, okay? But for today, plan to find the base to be the same, okay? This is step 1. We're going to get harder in the next couple lessons. So here's your homework today, page 69 to 70, numbers 1A, C, D, E, F, 2A, B, C, 4A, C, 5A, B, and 9. Have a great day, class, and see me if you need help.